So the frequency of this is n. None were censored, that means there's no censored value, and no two lives die at the same age. So it means that all the uncensored values are distinct. Or we say that the number of this uncensored value is 1. At the time of 9 death, the Nelson-Allen estimate of the cumulative hazard rate is 0.511. So it means that under this Nelson-Allen, we can calculate this cumulative hazard rate at 9, which is given by 0.511. And at the time of 10 death, it is 0.588. So again, here is calculate the cumulative hazard rate at 10, which is 0.588 under Nelson-Allen. Estimate the value of the survival function at the time of the 3rd death. So this aim is to find what is the survival at 3 by using the Nelson-Allen. It means that we have to find the cumulative hazard rate at 3, then only we can solve this problem. Solution for number 9. Let x be the random variable representing the mortality data. Then we have the following chart. So at the beginning, we have 0, where the frequency is n. And next, we have the death at 1, 2, 3, 9, and 10. The frequency of this death all are 1. So let's calculate the conditional frequency for the x, where x is slightly less than the xi. So if we choose x is 1, we have no x value which is less than 1. That is 0. If we choose x is 9, so we will have 8 values of the uncensored value which is less than 9. If we choose x is 10, we will have 9 values which is less than 10. And now we go to calculate the conditional frequency for the transition value. That is referred to this condition where the d is slightly less than the xi. So if we choose our x1 is 1, so we have a n0 which is less than 1. If we choose our x is 9, so we have n of the 0 which is less than 9. Similarly, if you choose 10, we have n of the 0 which is less than 10. And now we can calculate for the r by taking this value minus this value. So we will have n minus 0, n minus 8, and n minus 9. Given cumulative hazard rate at 9, which is 0.511, and the cumulative hazard rate at 10, which is 0.588. By taking the recursive formula, this equals to the cumulative hazard rate at 9 plus 1 over n minus 9. So H9 we know that is 0.511. So we solve this equation, you will have n which is equal to 21 and 76 divided by 77. So this is about 22. So therefore, we can calculate what is the cumulative hazard rate at 3 by taking Nelson-Allen So 3 is false on here. That is n minus 1 and n minus 2. So we try to substitute our n inside here. So under this Nelson-Allen, this cumulative Hazer rate at 3 equals to 1 over 22 plus 1 over 21 plus 1 over 20. So this will give me 661 divided by 4620. Therefore, the survival at 3, which is equals to the exponential to the power of negative 661 divided by 4620, that is equals to 0.8667.
Okay, so now for this question is similar to the, I think, question number 8 or 7. So you have to place all the data into this chart here. So now remember, we have a data from 2 to 8. This observation, this is my reference number. Okay, our data for this uncensored x value here. So we have data, but all are 1. Okay, that is from 2 to 8. Okay, so therefore you have all this condition frequency 8 and 9 here. Otherwise you wouldn't get 8, right? Because here also we have data altogether. Actually, I should put dot 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 2, 3 until 8. Okay, each of the x here, okay, has the frequency which is 1. Okay, and of course you have to find the R value that is based on this box from 1 to 10. Here also got the R value. Okay, here also got R value, but I skip only. Okay, but however, after that, you can see I calculated for the observation 2 and 3, because the question asked to find up to 3. So I need to consider the first 3 uncensored value. That is from n to n minus 2. Okay, so do not mistaken that this blank, this is blank. No, actually we have data, we have frequency, we have condition frequency, and we have the R value. Actually, in fact, it actually is until 8 here. Okay, so that is n minus 7 for this uncensored value when x is 8. Okay, but here we don't need to draw so many row, otherwise you have no space for draw the table. Okay, so we know that if you only consider the first 3, okay, that's only from n up to n minus 2. I think the rest should be no problem. Once you have the n value, okay, next should be no problem. Okay, so this is your solution for number 9. Okay, now we go to next. That is we come to the kernel distribution. Okay, from 10 onwards, we will involve the kernel distribution. Oh, really? Yeah. Then they call me. I spent 10 hours continuously for this video to edit. Okay, to edit only, not record, edit only. It's quite difficult. Okay, so we go to this question number 10. Okay. Okay, here we go.
Question number 10. From a population having density function f, you are given the following sample. That is this, from 31 to 51. Part A. Use the uniform kernel with bandwidth 5. Calculate the following. That for part 1, calculate the value of kernel smoothed density at 40. That is, we have to find what is kernel smoothed density at 40. That is, we have to find the kernel density at 40 so that we have this result, then only we can find the kernel smoothed density at 40. For part 2, we have to find the value of kernel smoothed distribution at 50. That is, we have to find this f at 50. So similarly, we need to find kernel's distribution at 50 so that we can use this result to determine this value. There we go. Number 10. Let x be the random variable of the given data such that bandwidth is given, which is 5. Then we have the following chart that this is the given data from 31 to 51. The number of observation of each data is 1, except 42 is repeated twice. So the probability for each of the data is 1 over 8, except this data 42, the probability is 2 over 8. Part A. Let x is uniform distributed in this interval from xi minus 5 to xi plus 5, where the bandwidth is 5. Part 1. Then the kernel density at 40 is given by these piecewise functions. For kernel density at 40, we have to substitute x is 40 and b is 5 inside this and also the interval, so that we can get the k value at 40 based on all the data xi. So we will have this kernel density at 40 based on xi, which is equals to 1 over 2 times b, where our b is 5 for this interval. And this k value at 40 will be 0 when other than this interval. That is, otherwise. And this is equals to 1 over 10. And rearrange this interval, so we will have xi bounded from 35 to 45. And this is 0 otherwise. So based on these intervals, only data 37, 39, 42, 45 inside this interval. So we only consider this.
Sorry.
To 1 over 10. So based on these intervals, only data 37, 39, 42, 45 inside this interval. So we only consider these 4 probabilities, where this 37, 39, 45 has same probability and 42 has probability of 2 over 8. So therefore, we can calculate the kernel smoothed density at 40, which is equals to the probability 1 over 8 multiply 1 over 10 3 times, and plus the probability for 2 over 8 and multiply this 1 over 10. So I will have 0.0625. Part 2. So I will have 0.0625.
Okay, so before we go to part 2, I hope you get it. Okay, so you have to remember, you have to rearrange this in terms of x, the xi, so that the piecewise function you can see that you can see very clearly that you only consider the observation that is bounded from 35 to 45 only. Otherwise, this kernel density value will be 0. So that means you only consider 37 up to 40 something, 45. You only consider 37 up to 45 only. Okay, so then only we can calculate, right? We can take the probability, multiply all the kernel density function for this observation. That is, we have 3 times, okay, of 1/8, okay, and 1 time for this 1/10, 1/2 times, and then this is 3 times that you can see from here. Okay, you can see from here, because you want to have this probability that I have a 3 times 1/8, okay, and then I have 1 time only, that is from 42, that is a probability 2/8, and then multiply the k value, that is 1/10. Okay, so this one should be no problem, you will get the answer easily. But the most important is to know how to rearrange the inequality in terms of xi. Let's go to part 2.
At 50 is given by this piecewise function under uniform kernel. For kernel distribution at 50, we have to substitute x is 50 into this result and also the intervals, so that we can calculate the kernel distribution at 50 based on all the data xi. So we will have this kernel distribution at 50 based on xi, which is equal to 0 for this interval when 50, which is less than xi minus 5, and this k value equals to 50 minus xi minus 5, and divided by 2 times 5 at this interval where xi minus 5, which is less or equals to 50, and which is less or equals to xi plus 5. And this k value is equals to 1 when 50, which is greater than xi plus 5. And simplify this, we will have this is 0 where your xi, which is greater than 55, and here will be 55 minus xi divided by 10, and you simplify this, then xi is bounded from 45 to 55, and this k value will be equal to 1, that is when the xi, which is really less than 45. So based on these intervals, we know that whatever the data less or equal to 55, we have to consider. In other words, we have to consider all the data. That means we have to consider all the probability. So whatever the data is less than 45, the k value is 1. That means these 4 data will have the k value is 1 based on this probability. And the data falls on this group will have this value. So that means these 3 data based on this probability will have this value. So here we will have 3 times of 1 over 8 and multiply this k value, which is 1, and plus I have 1 data where the probability is 2 over 8 and multiply this k value, which is 1. And I have 3 data which is false on this group that with the same probability, which is 1 over 8, and multiply this value. So the first value is a 55 minus xi, which is 45, and divided by 10. And the next data will be 48. So this is a 55 minus 48 divided by 10. And the last data will be 51. Substitute inside here, I will have 55 minus 51 divided by 10. So this will give me 0.8875.
Okay, class. So once you have rearranged the inequality, you can see that whatever the data greater than strictly greater than 55 is 0. Okay, so you look at our observation here. Our observation is we do not have 55. Whatever greater than 55 will be 0. So that means we don't have any observation greater than 50. That means we have to consider all the data here. Okay, so some data will multiply the 1, some data will multiply this result, depends on your xi. Okay, so whatever less than 45, strictly less than 45, the k value is 1. So if you look at our data here, less than 45, strictly less than 45, we have 4 data. Right, we have 4 data that the k value will give 1. That means we will take this probability, multiply the 1. The rest we will take 1 over this probability, multiply the value from the calculation. Okay, that is here. Right, we have 3 data where the k value is given 1. Okay, sorry, 4 data. We have 4 data that given the k value is 1 with the different probabilities there. Okay, and next we have 3 data. Okay, 3 data falls on this group that will have this value, depends on your observation. Okay, so once you simplify, then you will have this result. Okay, so this is the part A under this kernel uniform. Uniform very easy to calculate. Okay, let's go to I think next is triangular.
5. Part B. Use the triangular kernel with bandwidth 5. Calculate the following. That is the part 1 to find the value of kernel smoothed density at 35. That is our aim, is to find this kernel smoothed density at 35. So first of all, you have to get what is the kernel density at 35. So that if you have this result, then you can determine this kernel smoothed density at 35. For part 2, we have to calculate the value of kernel smoothed distribution at 55. That is, we have to find this f at 55. So again, we need to find kernel distribution at 55, so that when we have this result, then we can solve this problem. Part B. Let x is triangular distributed in this interval, which is from xi minus 5 to xi plus 5, where the bandwidth is given, which is 5. Part 1. The kernel density at 35 is given by this formula. For the kernel density at 35, we have to substitute the x is 35 and the b is 5 inside this and also the interval, so that we can get the k value for each data. So the kernel density at 35 based on xi, which is given by this piecewise function, that is a 5 minus 35 minus xi, and take the modulus and divided by 5 square in this interval where xi minus 5, which is less or equals to 35, and which is less or equals to xi plus 5. Other than this interval, the k value will be 0. So if we simplify, then we will have the following: 5 minus 35 minus xi divided by 25. In this interval, that is, the xi is bounded from 30 to 40. Other than this interval, the k value is 0. So based on this result here, that only 3 data inside this interval, that the data is 31, 37, and 39. Now, since these 3 data have the same probability, and which belongs to this, so therefore the kernel smoothed density at 35 is given by this result. That is 1/8 is a probability for these 3 data, which is false on this. So I will have 5 minus 35 minus 31 and divided by 25, and next will be the data, which is 37. So I will have 5 minus 35 minus 37 divided by 25, and the last data will be 39. So I will take 5 minus 35 and substitute my 39, and then after that divided by 25. So I will have 0.025.
Okay, so once you have rearranged this interval, so obviously we know that we have a 3 data false on this group, that is from 30 to 40. So if you look at the chart, our chart here, so we have 3 data only, that is 31 to 39. Okay, with the same probability. Okay, the rest will give you 0. Okay, so you only consider this 31, 37, 39. Okay, so therefore you will have this result. That's only 3 data: 31, 37, 39. Okay, so you will have 0.025. So we carry on to part 2, still under this triangular kernel distribution.
Part 2. For the kernel distribution at 55, then we have to use this formula to calculate. That means we have to substitute the x value, which is 55, and the b, which is 5, inside here, and also the interval, to get the kernel distribution at 55. We will have the following piecewise function, where I substitute the x is 55 and the bandwidth b is 5 into here, and also the interval. So next I'm going to simplify these piecewise functions, that this will give me 0 when I, which is 50, more than 60. So the next will give me 60, which is minus xi square divided by 50 in this interval where the xi is bounded from 55 to 60. So this will give me 1 minus xi minus 50 and divided by 50. At this interval, when the xi, which is bounded from 50 to 55.
I have a square here. I missed out the square, but it's okay. The answer will be correct. I missed out the square. Okay, carry on.
So the last result, the k is 1 when the xi, which is 50 less than 50. Based on these intervals here, so that is whatever data is less or equal to 60 will be considered. In other words, all the data to be considered because which is less than 60. So whatever the data which is less than 50, the k value is 1. So the data from 31 to 48, which is less than 50. So the k value is 1. I have 5 times of this data where the probability is 1 over 8, except 42, the probability is 2 over 8. And this 51 is falls on this interval that with this value. So the kernel smoothed distribution at 55, which is given by 5 times of the probability of 1 over 8, multiply this k value, and I have one value with the probability is 2 over 8, and multiply the k value is 1, and I have one value falls on this group. The data is 51. So I will take the probability, multiply this value, that is a 1 minus 51 minus 50, and divided by 50 square, and I will have 0.9975.
Okay, so once you have rearranged, you can see that we don't have any data greater than 60. That means all the data may be considered. I think we don't have data which is greater than 55. Okay, let's look at our data. Yeah, our maximum data is only 51. Okay, so in other words, for this problem, we only consider these two pieces. Because we don't have any data greater than 60, we don't have any data falls on the 55 to 60. So our data is only either is this group or this group. Okay, so clear. So that means, and these two no need to consider, only consider one and this third piece. Okay, so the next should be no problem that you know how to calculate once you know what data or what observation need to consider. Okay, and after that, I think the part C quite simple. That is for the gamma kernel distribution, quite straightforward.
Minus 50. We go to part C. Use the gamma kernel with parameter alpha is 2 to calculate the value of kernel smoothed density at 30. So that means we have to find what is this kernel smoothed density at 30 based on this gamma kernel with this parameter alpha is 2. So for part C, we just use a formula for the kernel density at 30 from this gamma kernel. You can get this result to solve this problem. Part C. Let X be gamma distributed with these parameters alpha and xi divided by alpha, where alpha is 2. So the kernel density at 30, which is defined by this formula, that I'm going to substitute x is 30 and the alpha is 2. So I will have the following, that this kernel density at 30 based on this data xi, which is equals to 30 to the power of 2 minus 1 and multiply the exponential to the power of negative 2 times 30 and divided by xi. And this total divided by xi divided by 2 square and multiply the gamma of 2, which is equals to 120 divided by xi square and multiply the exponential to the power of 60 divided by xi. So I will have the following. This is the data given that from 31 to 51, and the number of observations all are 1 except 42, and this repeated twice. And the probability of each data is 1 over 8 except 42. The probability is 2 over 8. And next is the kernel density value at 30 based on each data here. So we will have this by substitute all the x value inside here. We will have all this value. So for example, when xi is 42, so if I substitute inside here, I will have 120 divided by 42 square and times e to the power of 60 divided by 42. So please take note that for gamma kernel, we have to consider all the data. Thus, the kernel smoothed density at 30 is given by this. So I will take all the probability here, that's 1 over 8 except this data, 42. There's a 1 over 8 multiply all this k value. So 120 divided by 31 square times e to the power of 60 over 31 plus all this except this until here. There's a 120 divided by 51 square times the exponential to the power of 60 over 51 and plus this probability 2 over 8 multiply this k value. There's a 120 divided by 42 square multiply the exponential to the power of 60 divided by 42. So this result is 0.0162.
Okay, so we have done this question number 10 very long. Now remember, for the gamma kernel distribution, we no need to consider the interval. All the observation have to consider. Okay, just substitute into the formula. You have to consider all. Okay, so this is a solution for number 10. I think we have no time to continue the rest. The rest we can continue during our tutorial hours. Okay, we have to pick attendance. Okay.